Hey everyone, good morning and welcome to our session. So I think we only have three people who have joined today. So I guess a lot of people may be having Monday blues. We'll wait for another minute and we'll get started after that. Just to give you a small agenda of what we are going to start with. So in the last class, we had covered Word2Vec. We had discussed the theory part of it and we saw the two variations using which how we can create the Word2Vec models. In today's lecture, we are going to get into the coding part. So we'll build machine learning models using Word2Vec and we'll compare the results with the previous approaches that we have seen. Okay. And after we see all these things, we'll talk about machine learning other models. So I'll talk about what are the different models that we can use while doing any kind of uh, modeling. And also, in the next lecture, we'll start with deep learning approaches as well. But as I said before, the goal over here is not to explain you the working of the models because you already know like how logistic regression works, how random forest works, or let's say how does RNN LSTMs work, right? You already have gone through the lectures. So we'll be directly using the models and we'll be probably just in brief discussing about pros and cons of each model. Okay, so that's how we'll be progressing with the topics. Mm, okay, so for today's work, we'll be taking project from IMDb. Okay, just to confirm, I'm audible, right? Can anyone just quickly type in a one? Pratija, Harshita, Subhash, Vishal. Am I audible? Okay, cool. So we'll be talking about a data set which we have taken from IMDb, and using that, we'll be performing classification using Word2Vec. Okay, so I'll be sharing the data file with you. You can get it from Kaggle as well. Just a second. All right. Cool. Let me share my screen. I'll just show you a couple of interesting things. Because my laptop is very slow today, that's why it's taking much more time than usual. Okay. I hope everyone can see the screen. Let's begin. So in today's lecture, we are going to start with just we are going to continue with Word2Vec. We had discussed already. So we'll see the code of it. We'll build a mini project using the feature vectorizations techniques that we have learned, right? So one of them is using Word2Vec, and we'll also discuss about the count-based approaches in code. Okay. Now talking about the machine learning in general, we'll also talk about ML, which we know uh, has been specifically you have like classical ML and your deep learning, right? So you have deep learning and you have classical ML in which you have normal algorithms, the supervised and unsupervised algorithms like random forest, logistic regression, all those are the classical machine learning models. Okay. Now let's say we'll discuss what are the different ways of building a project and then we'll go to build the project. Okay. So talking about how do we build the project. So in machine learning, we have multiple steps through which we finally come to the end output. For example, you take any particular project. For example, we had taken sentiment analysis, right? And we had seen Twitter example of how we can build the projects for sentiment analysis. Even if we talk about, let's say, another classification problem, let's say email spam, where you have to classify whether an email is ham or spam. That also is a pure problem where you are using NLP, right? Because you will be reading the text of the email to decide whether it's a ham or spam. Okay. So generally in NLP, you have some steps which you'll follow, right? You like, for example, you get your data, you get the data. Once you have your get data, you process the data. So process as in you clean the data, right? So you clean data. Once you have cleaned the data, you will convert it to numbers. So that's where vectorization happens. You convert the text into numbers. Once the text is converted into numbers, you start building the models. To build the models, you can use machine learning or deep learning. To vectorize, you can use count-based or prediction-based approaches. Once you have built your ML or DL models, then we go to checking the performance. So here we go for the evaluation. If the model looks good, we finally go with deployment. Okay. Talking a little in detail. So getting data, generally in NLP case, it's generally either from Excel file, because either you are analyzing like feedbacks, customer surveys. So maybe a lot of times people may have that in Excel files, or you may have it in SQL tables. Like if the data size is very huge, you will see probably SQL table, one of the most common sources of getting the data. Clean the data, we already have discussed, like you remove stop words, lemmatization, removing punctuation marks, converting it to lower forms, and or converting to upper forms. But apart from that, like removing some links, HTML tags, cleaning the code, all those things are there in data cleaning. Turn-based, we already know that you can use bag of words, TF-IDF, binary vectorizer, count vectorizer. Over here in prediction-based, we have Word2Vec, which is what is the main thing. Then you go to models. In machine learning, you have models like logistic regression, you have random forest, you have naive Bayes, you have SVM, right? All these are classification models. Apart from this, there are many other models, like you have XGBoost and all that, right? Since you are converting it to numbers, you can use any classification models, right? It doesn't matter. Because over here, when you have vectorized it, now it's set of numbers. So you can apply any model, because any classification model, because it's not like specific NLP problem. It's a general problem, because now you only have numbers. Coming to deep learning, you can use deep learning classification models like CNN. You can use RNN, LSTM. Okay. Then you can use transformer-based models like BERT. There are variations of BERT as well. Right. So these are some of the commonly used classification models that we talk about. Talking about deployment, then once the models have been built, you check the performance of the model using relation metrics like accuracy, precision, recall, uh, F1 score. What else? You use log loss and a couple of other custom metrics as well. Right. Okay, so once you have evaluated the model, we finally go to deployment, where we deploy the model by hosting it on cloud platforms. So either right now, like there are three main cloud platforms which everyone tries to use: AWS, GCP, and Azure. Okay, so you build the model and you finally deploy it on the one of the cloud services. Have you guys studied about deployment? Can you type in a 1 or 0? Do you have an idea of MLOps? 0? Okay. So MLOps has not been covered for any of you. Okay. Okay, no issue. Like you can just imagine that you have built the model, but you have built the model on your Jupyter notebook. So how do others utilize your prediction, right? If you can add your model on cloud, and from cloud, people can make use of predictions anywhere across the world, because it's like in shareable format, right? So the model will run over the cloud, and your predictions will get passed to whoever needs it. It's a, you can say it's a more efficient way of using your predictions, because if you were not doing it, you will have to probably run the model on Jupyter Notebook once it's trained. But if you want to send out predictions, what will you do? You, how would you share the file, right? Let's say you have built the model, it's a pickle file, but now any business person, if they want to run the predictions, they wouldn't understand how to like run the notebook, because one thing, the accuracy that you are getting on your notebook will differ from the other person, so it's not consistent, right? Second thing is, the business person may not know how to run the Jupyter notebook, or they may not understand like what is training and testing. So if we can deploy and set it up for one time on cloud, and now the pipeline is fixed, all we have to do is just keep like triggering the predictions, data will start flowing in, and everyone anywhere across the world, as long as they have access to the cloud, they can utilize the predictions. They don't have to worry that the results will be different, or the notebook is not shareable, or how do we share it with 1,000 people? You can't just keep sharing the notebook. It's not like an efficient way. The better way is just deploy it from cloud. Everyone logins and fetches the detail. Okay, let's start talking about the project, the mini project that we are going to build. So we are going to talk about IMDb dataset, using which we are going to perform. Just give me a moment. Hello. Hey, yeah. So we'll be continuing with sentiment analysis. So we'll talk about how we can perform sentiment analysis. Then once we do that, we'll compare the results of classification, what we had earlier done on using heuristic approaches like count-based approaches, and we'll compare it with. So I'm talking about the feature vectorization things, okay, where we are converting text to numbers. So we'll compare these results between count-based, prediction-based, and also we'll try out multiple ML models. Okay, that's what is the goal for today. Okay, one thing, when it comes to machine learning, when we build the models, in machine learning, there are multiple ways through which you can build the models, right? But let's say if you are not using machine learning and you want to still get the output, one thing you can do is you can use rule-based approaches, also called as heuristic approaches. Right? Heuristic approaches means, let's say if you want to classify something which is like an email into whether it's a spam or ham, and let's say you don't want to use machine learning to classify, to build the model. So what we can do is, instead of building a model, we'll check for each email, let's say email 1, email 2, and so on. For each email, what is the, let's say, count of positive words divided by negative words, right? I'm just creating one of my custom rule, like positive by negative. And based on that, we define, let's say, probably a rule, probably saying that if let's say that, so here positive means like ham words, negative means spam words. Okay. Or actually, we can make it a little direct. So let's say you'll calculate the count of words which sound spammy. Okay. So let's say the spam words divided by the count of ham words. Okay. Where ham words are words which probably sound like hammy, the ones which sound like spammy. Okay. For example, let's say that lottery, right? Lottery can be a word which sounds like spammy. Okay. So that's how we identify it. And let's say based on this ratio, based on if the ratio is greater than, let's say, 1, or let's say very higher, like greater than 1.5, then you will say that spam is a higher quantity, right? So you will try to classify it as spam. Okay, so this is a very simple heuristic based approach, and that is why the results of this also will not be too accurate. Okay, the the results will not be too accurate because it's a very simple rule. Generally, you need for text data much more dynamicity. But let's say if you are solving like a very simple problem where you don't have a lot of data and you feel you can think of a rule which can help you solve the problem, then you should have this idea in mind. Okay. Same thing, you keep doing it for all the emails. The same rule will apply everywhere. Okay, so this was a rule-based approach. If you don't want to go ahead with a rule-based approach, then we try out machine learning models, which we have discussed: logistic regression, XGBoost, random forest, Nebase, right? SVM. Okay. If ML is not giving you proper results, okay. Let's say you feel whatever results that you're getting with ML are not that good. And considering you have done your hyperparameter tuning, you have done your feature engineering, you have tried your best to get the best results, but still you're not satisfied with what you're looking for, then only go to deep learning. Okay. Prefer you don't go to deep learning, because if you go to deep learning, there will be a lot of challenges that will come in. But if you are sure that ML is not solving or heuristic is not solving, then only go to deep learning. Okay. Else, I don't recommend people to directly go to deep learning, or avoid deep learning as much as you can. But let's say others are not giving you results after you given your 101%, then go to deep learning, try out the classroom models like CNN, RN, LSTM, right? But so we had discussed about pre-trained models and custom models. So you can use, by the way, like pre-trained models as well. So pre-trained models are the models which have been trained by some other companies, right? For example, they have their APIs, which you can directly use. Okay. API is nothing but you can consider like a connection between your notebook and that particular website which has built the model. So let's say this is where you are writing your Python code. This is your Jupyter notebook. Okay. From your Jupyter notebook, now I want to utilize that particular model which some other company has stored it somewhere, right? Let's say they have stored the model over here. So I don't want to train it. I just want to utilize their predictions. So what will I do is I will connect to that particular source using an API. Okay, so I'll send a request saying that, hey, I have some data and I want to get that predictions for that particular data using your model. So can you share the results of the data that I'm sharing to you over here? And that's how you will get a response. So you send a request where you ask for permission to get predictions. And here you get a response that you have permission to fetch the results. Once the connection is created, now you can simply pass the data and it will keep giving the output. Okay. So this is where you don't have to train the model. Okay? It's pre-trained. But if you have to train the model by yourself, then obviously you can use the above approaches where you can build the model using your own custom data, like custom methods. Okay. Coming to deep learning. So in deep learning, as I said, uh, there are many companies which offer this API based logics, and I think a lot of them are pretty good. A lot of times you don't have to train the model by yourself. You can save your time by just using their APIs. For example, companies like Google, Amazon, they have their own APIs. You might have heard of BERT, you might have heard of many other models which are very common. So this is like a transformer approach. Transformer are like one of the most Transformer are like one of the most difficult approaches. Okay, but it's very powerful, but unnecessary. You don't have to add it. Only if it adds value, then only we need it. Anyways, going over here. So if you are not satisfied with ML, go to deep learning. In deep learning, just remember one thing, that you will lose out on feature insights, right? You won't have model explainability because it's deep learning. So you don't really know what are the features, right? That's what is the main issue with deep learning. Second thing, if you try to deploy the deep learning models, it's much more far complex than deploying simple ML models. Okay. So deploying deep learning is very difficult. I mean, I won't say very difficult, but it's very complex. Okay. So ensure that you probably try to stick around ML. If required, go to deep learning. Okay. Third thing is, will use deep learning only if there is a point in using it. Like deep learning is giving you 90% accuracy and machine learning is giving you like 88% accuracy. Would you want to switch to deep learning? Probably not. Okay. Unless and until there's a strict restriction that you want 90% accuracy, the difference is not too much. With ML, you're getting 88. With deep learning, you're hardly getting like 2% improvement, which is 90%. So in my opinion, it's not like a good thing because unnecessarily you are increasing your complexity with deep learning. And obviously, you're losing out on understanding which are the most important features. Another thing is you should know that there is a rule called as Occam's razor. Okay. So Occam's razor rule says that there are two trade-offs that you need to balance. One is about keeping models simple, and one is about getting a good or a accurate model. Okay, so what it says is, when in life you are given a choice to choose between two machine learning models, let's say one machine learning model is neural network, giving you 88% accuracy, and another model is logistic regression, which is giving you, let's say, 85% accuracy. Now, the rule says that choose a model which is simple and also good, okay, instead of choosing a model which is the opposite. So, for example, over here, if the difference between them is not much, and considering both the models are giving you good results, right? Let's say both of them are giving you good results. For example, let's say you wanted 80% accuracy, and now you have gotten 88 and 85. Okay, so that means both are good only, right? So if that is the case, the Occam's razor says that prefer a simple model. Between neural network and logistic regression, we all know the simplest model is logistic regression, right? This is much more simpler. So the Occam's razor is saying that the rule says that don't try to focus on increasing complexity. Instead, try to focus on keeping things simple. Okay, but that doesn't mean that you compromise on the quality. Ensure that both of them are giving good results. But let's say if neural network is giving you 90%, this is giving you 70%, and your passing criteria is like 80%, then go with neural network, because then you don't have a choice. Okay, only if you have a choice where both are giving you like good numbers and the difference between them is not much, then only go with a simpler model. And that is what was the rule from Occam. Okay, so Occam razor is a general life rule as well. If you are given like two choices where you're getting two same results, go with a life choice which is much more simpler than going with a much more complex life choice. Okay, so now we'll talk about building ML models. We'll discuss what are the different ways through which we can build all these models, and we'll get into the code. To introduce the problem that we are going to solve today, so we are going to solve the problem of IMDb dataset. So where we are going to analyze the data. Okay, so here we are going to perform sentiment analysis. And using sentiment analysis, we are going to classify whether a particular review. I guess everyone would be aware of IMDb, right? It's a very famous movie review platform, right? If not, we can quickly have a look at it. Using the IMDb platform, using the movie review platform, we'll classify whether a particular review uh, is it spam, is it ham? Say not spam, huh? Is it positive or is it negative? Okay, that's what we are going to check. So we'll classify it as positive or is it negative? That's what we have to do. Okay, so let's say if you feel that a particular review is, let's say the review one is movie is the movie is bad. Second review is movie was awesome. So you can understand that this is going to be a negative review and this is going to be a positive review, right? And that's what we have to do. Okay, so let's go to the code and let's solve this problem together. Okay. Okay, so over here you're importing the libraries, then you're reading. Okay, so actually let me write it over here. So before we go over here, let me just show you quickly IMDb data. So this is the so not this is the developer side. Okay, this is the official IMDb website where you can see like list of movies which are there and what are the reviews. Like for whatever show that you want to see reviews, you can see some of the reviews which will be present over here. Okay, and based on that, like for example, if I open this particular uh, movie or TV show, you would be able to see the reviews. Yeah, so you can see the reviews over here. Let me click on this. And now that's what we are going to do. Like we are going to see that how is the sentiment of this review. If I pass this entire text data, is the movie trying to convey a positive or a negative meaning? So on Kaggle, we already have a sample data created and we are going to use that. So this is the data of 50K movie reviews, which we are going to leverage. Here, you already have 50,000 dataset for which we want to do uh, training and testing. Okay, so you can see some examples like the review is given. One of the reviewer has mentioned that just after watching this, and the label for it, positive or negative. So it's a label data. Okay, cool. Let's go to our code. So let's start by importing NumPy and pandas. Then we have a CSV file, which I'll be sharing with you. We are storing that in a temp.df. From temp.df, since we have 50,000 total reviews, I'm just extracting the first 10K, just creating a sample just to make things faster. We'll start with a sample. Once we have sorted for 10,000, we'll just increase it to, let's say, 30,000 or 50,000. But first, let's see what results we are getting with 10K. Generally, whenever you're given like a bigger problem where you have huge data, instead of building the models on complete data, start with sample and see what kind of insights that you are getting from the sample, because the time it will take to train the models and get the results using a sample data will be very less compared to training on, let's say, millions of rows. So you start with sample and then go to building the models on the entire data. That's the first recommendation. Okay, coming to your data. So this is your DF head where you can see the review and the corresponding sentiment. Okay, so over here, since we have taken like the top 10,000 reviews, we are, so here we have review column and sentiment column. So we are fetching the review column and we are fetching the index one review. Okay, so which is a wonderful little production. So that's what the review says, right? You can read the review. This is just one example to show you how the data looks like. Since this data, when it was created using web scraping, and that is why you have this HTML tags mentioned over here. So we need to clean all this HTML tags and we need to ensure that there is no HTML code involved. Okay. Next, we'll check the unique values of the sentiment column. So you can see like there are 5,028 positive reviews and 4,972 negative reviews. So it doesn't seems like a imbalanced data set. It looks quite balanced only, right? The difference is not much. So I will assume it's a balanced data set. So if it's a balanced data set, I don't have to care about handling the imbalance. Okay. I'll check for the missing values. So you can clearly see that both the columns don't have any missing value, which again is a very good thing. I'll check for duplicates. I can see that there are 17 rows which are having duplicates and we are just dropping it. Okay, nothing more than that. Let me hide the warning.
Sentiment is a column somewhere, or sentiment you have already taken out how that came out. This one, sentiment. Okay, this one. Okay, columns. Oh.
Yep. Warnings dot filter warnings. Okay, so let's run this again. So now we have dropped the duplicates and we are checking the sum of duplicates. So now it's 0. from 17. That means we have dropped all the duplicate removes. Okay. Now we'll do some basic pre-processing where we are going to remove tags, lowercase, and remove the stop words. So talking about how we'll do it, for the first one, where we have to, let's say, remove all the tags as in like wherever there are HTML tags. So HTML tags are represented by this command where they will write some keyword here. Like for example, BR stands for break. Okay, so this is a command which is used for like telling that there are breaks between multiple sentences, right? So you will have some text over here, which is your main text. Let's say movie is nice. And then HTML name, you will close this tag, okay, like this. Then you will go to the next one. For the next one, you'll again like write a tag and you will write the next review. Like this is not what you'll see on the screen, but uh, in the backend, this is how the HTML is creating the code, or like this is how the code has been written for the website. Yeah, HTML is like a front end language, but still you can imagine like at the back you will have a code looking like this. Movie was boring. Okay, and this will keep continuing. Okay, so BR is one example, but you have many other tags. For example, when you're giving like a big headline on the IMDb essay, you will have a header for that, and based on that, you will be giving the headline. For example, IMDb movie reviews like this. Okay, so the main thing is we need to pre-process this tags. We don't need this tag. Okay, we only need the text data in them, and that is what we are doing over here. We are checking this lower than values, like any form of lower than occurs, we'll simply remove it. If you want to understand what is happening over here, we'll simply copy this. We'll just first copy the pattern. So re.compile will do nothing. It will just match this particular pattern. And wherever there's a match, it will return that particular object, like that particular portion of the string. Okay, that's what it will do. So going to regex 101. Choose Python, give the string. Right. So if you want to understand what is happening over, you can read over here that okay, dot matches any character except for line terminators, right? So it will match either zero or more number of characters which are there with less than symbol. Okay, that's what it is just trying to do. Okay, now over here, this particular thing can get repeated, and that's what asterisk and question mark is saying. It's saying that it matches the previous token either zero times or it can be till unlimited times. Okay, that means it's just checking if it's present or not. Even if it's not present, it's fine. It will check for the later thing, which is the closing command, which is the like greater than symbol. The reason we are creating this pattern is we know the tags are represented in this form, right? So whatever it's written inside this, we know it is going to be a tag. And that's what we are checking. We are checking if we have an opening symbol and if we have a closing symbol. If we have an opening and closing symbol, I'll assume whatever text is coming in between them is going to be a tag, right? For example, over here, if I have an input, let's say uh, VR, okay, this gets flagged. Okay, to understand that is a this thing tag. Okay. But let's say if I don't close this, like if I keep writing something else, something else, something else, something else, and if I don't close it, until I close it, it won't understand it's a tag. Wherever I close it, it becomes a tag. And that's what we want. Okay. So it will take care of tags. So let's say if you have code like this, the movie is nice. And then I close this. Okay, so now over here, BR will get flat, BR will get flat, BR will get flat. The only reason why it's not highlighting over here is because it's matching only the first one. But if we want to match to 0 to 4, we can check for different ones as well. Okay, cool. So one thing, like in nowadays, no one remembers regex that much. Like if you know it, well and good. But if you, even if you don't like remember everything, it's good. It's not an issue. No one asks regex in an interview, and everyone knows that you can get information from like ChatGPT and online tools to form the regex expression. So don't worry about regex too much. Just focus on the core part. Okay. So now we will handle the tags. We have removed the tags. So here we get a match, like which is the string where we are having that particular token. re.sub substitutes it. So whatever string is where you have a match, for example, let's say this string returns, let's say this is returning uh, BR. Okay. So now you will replace BR with a blank string. Okay, that's what we are doing. So now through this, you will be able to clean the text. You return the clean text. And now let's run this function on the review column. And now you're updating the review. Okay, cool. So now you can see the data. You won't have your tags present. For example, if I show you review, and let's say if I show you the index one. Okay. So here we have removed the tags. So what the tags over here? Yes. So see, BR was over here, right? This BR, this BR. And now we don't have the tags anywhere over here. It has been removed. Okay, after wonderful little production, there is no tag. Okay, so now we have taken care of tags, but now we still have other processing, pre-processing things that we have to do. So let's go. Now what we are going to do is we'll make everything standardized. So we are just converting everything into lowercase. Okay. Once everything has been converted to lowercase, we'll remove the stop words. So to remove the stop words, we know we need to use NLTK. So from nltk.corpus, import the stop words. Now, to get the list of stop words, which are the stop words, you can just get SW list. If you want, I can show you the list of stop words which are defined in NLTK, English library. So these are the stop words which exist, and you can go through all the list. Okay. Anyways, once we have the list of stop words, what we are going to do is we are just going to remove the stop words. So you just need to write the command for checking if the particular review contains the stop word or not. If they contain, remove it, else don't remove it. And that's what is happening in this list. It's checking that, hey, for item in x dot split, which means that if like split means you are splitting it by spaces, right? So basically you will get all the words through this. Okay, X means the review. You're splitting the review by spaces. So item becomes all the words. So simply saying like X is, let's say, a sentence. The movie is interesting. If I use split over here, what will happen? You will get, I mean, this will not be a list. This will be a string. So what you'll get over here, you'll get a list. You'll get the movie is, because by default you're splitting it by spaces. Interesting. Okay. So now once you have stored all these words in a list, I just need to iterate through this list, right? That's what is happening. For item in this particular list, if that particular item, that means if that particular word is not in the stop word list, if it's not in the stop word list, what we'll have to do, we'll have to append it, we'll have to keep it. And that's what it's saying, that if it's not there, simply add it in the list, just store it in the list. That means just keep appending it to the list. Okay, so now we'll get the list of all the words which are not stop words. So here you'll get like movie and interesting. Okay, because the other two words will be stop words. Okay, and that's how your list would look like. Right, so over here you get the list, and once you have received the list, what we'll have to do, we'll have to convert it back to text. To convert back list to text, you'll have to use join function. Okay, in join, specify by what do you want to join. So let's say I'm saying join it by spaces. That means both these words will be separated by spaces, so that you get an output which would be separated by spaces. Movie space interest. Okay. Split and join. Remember, split converts string to list, whereas join converts list to string. Okay. And that's what is happening over here. You're first applying the split function over here to get the list. Once you have received the list, you are again applying the apply function to convert the list into the string format. Okay. So now the final output will be in form of string. Okay, with no stoppers. Okay, so let's check the data. Okay, so you won't see any stoppers. I can just quickly compare one sentence. Reviews. Okay, and let's say if we compare it with the older one, let's see if we can find some stop words over here. Yeah, so for example, here you have right? In the above one, you have the, right? You have is. So let's see if those are present after removing the stop. Has been removed, the has been removed, is has been removed, right? So you can see that the stop words are getting removed. Okay. So now once the stop word has been removed, we'll now focus on creating the ML models. To create the ML models, we all know we need to create X and Y variables. So in this case, where your data has only two columns, where one is a review column and one is a sentiment. So obviously sentiment will be your Y variable and you will be classifying it based on the review, right? So let's do that. X will be your first column. So that's what we are saying. Keep it as the first column. Take all the rows and take the 0th column. Now Y will be your sentiment column. That's it. Okay. So the reason why we are using ilog, everyone I hope knows that you need to pass X as a 2D variable. You can't pass it as a 1D variable, but Y has to be passed as a 1D variable, which is a series. And that is why we are passing it by directly writing the column. Okay. Here we need to use slicing. We are slicing rows and columns so that it becomes 2D. Okay. So now if you print X, you can clearly see it's a data frame, which is a 2D object. Okay. If I print the shape, it will have two-dimensional shape, right? You see 1 and 2-dimensional. But if I print the shape of Y, it will have only one-dimensional shape, which will be just a tuple. Like you can see, this is a simple tuple. It doesn't have the 2 dimension. Second dimension is not present. Okay, simple basics of ML. You can see your Y. Oh wait, did we convert Y? Oh, we didn't run this. Yeah, so you can see Y is like positive, negative, and so on. But the issue is this is all in now text format. This is all in text format. The machine learning algorithms won't understand the text data. We need to convert this to numbers. So we have cleaned the data. We have divided X and Y variables, but still let's clean it. Okay. I mean, not clean it, but pre-process it to convert text to number output. Okay. To vectors. So to convert the text data into numbers, let's first convert the Y variable. It is positive and negative. So I can simply use a label encoder to convert to 0 and 1, right? So label encoder simply checks how many number of unique categories you have. Here, let's say you have positive and negative, right? So it will give only two numbers, which is 0 and 1, right? So whichever is appearing first, let's say positive, will get a number 0, and whichever is coming later, let's say negative, will get the number 1. Okay. That's how it will encode. If you had one more category, let's say neutral, then that would have been given 2. Okay, that's how label encoders work. Okay, so now we'll go to sklearn.preprocessing, we'll import label encoder, we'll call the label encoder function. The pipeline is very same across any general machine learning algorithms. How do you like build ML models? You import it, you you instantiate the object, and then you use fit predict. But in case of, let's say, PCA, or in case of any transformation algorithms, or let's say standard scalar, min-max scalars, you have to use first call it and then use fit transform. Okay. So over here, this will transform your data. Okay. So one thing, just remember that this, I would say, is not the best way going about. We are just starting with like a neutral way. So you're going to transform your data where we are, where we are getting your ones and zeros list. Okay. Once we have done that, we are importing the train and test. This is again, I think you already know, for splitting into X train, X test, Y train, Y test. Split X and Y, train and test of 80-20, random state as one. X train dot shape, random state is only to ensure that you get consistent results, and whenever you run the node, the results should not change. Okay, and also to ensure you are doing random sampling when you are creating this variables. Okay, good. Yeah. So for random sampling and to maintain the state. So you'll get the shape. You can see the shape. You can see uh, you have converted X train, X test, Y train, Y test. Now it's time to convert the X columns into numbers. Y column we have converted into one and zeros, but X variable, these things we need to convert to numbers. Now to convert the X variable into numbers, we can use vectorizer, right? So this we are starting with a count based approach, right? And slowly we'll go to the prediction based approach. So here we are extracting the count vectorizer, which we discussed for the Twitter project as well, where we are taking the feature extraction model. So we are instantiating the count vectorizer. Now we'll again do a fit transform. So you can see that we are doing a fit transform only on the training data, but we are transforming only the testing data. Okay. And I told you last time as well, like as an interview question, you can be asked why and like where would you use fit and transform, right? So you generally fit the particular vectorizer only on the training data. You never fit it on the testing data, okay, because of data leakage issues. So you'll fit it on the training data, you will transform the training data, and similarly, you'll transform the testing data. You'll convert it to array and you'll store it as extrain bag of words and extest bag of words. Okay, so this is your bag of words. Why bag of words? Because you're using a count vectorizer, which will simply convert the reviews into the count numbers, okay, based on the count. So you can see the shape. As you can see now, the matrix has been created because you have 48,282 words, right? The list of words. Okay. So if you want to see an example of this, we can quickly see a small example. So I can just show you extrain dot head. Oh, we have converted to array. Just let me fetch. So I want to fetch, let's say, the top 5 rows, and let's say I want to fetch the top 10 columns. Okay, so this is how your matrix would look like. You have the top 5 rows and you'll have the top 10 columns over here. I mean the 10 columns, but you have like 8K rows and 48,000 columns. So this is based on count. And as I said, the main issue with count is sparsity. Majority of lines you'll have zeros only because this is for, let's say, the first line represents a review one, second line represents a review two, and so on. And you can clearly see for a particular review, out of 50,000 words, it may contain only hardly 100 words, right? So it will have zeros majorly once places where it is containing that particular word. Okay. And this is all defined based on unique words. The column will be all words, words, words. Okay. This is how your matrix looks, which is your bag of words. Okay. Let me comment this. Okay. Or let's keep it. Okay. So now we'll build the model because now we have converted the X data and we have converted the Y data. So we are ready to build the ML models. To build the ML models, we are starting with name base. So have you studied name base, by the way? Can anyone quickly confirm in the chat if you have studied name base? 1 or 0? 1? Okay. So good. I hope everyone remembers name base, and if not, I would expect everyone to do the revision. Actually, I had asked you all to revise it before coming for this lecture, but still, if you haven't revised it, please do revise it. As I said, since it's already covered in your curriculum, I won't be spending time to cover the same thing, but all I'll be doing is just telling you how we are using it, right? So name base is a classification algorithm which works on the concept of probabilities, like more specifically conditional probabilities. And using the Bayes theorem, you try to predict the probabilities. Gaussian name base is a specific type of name base in which you assume like the distribution is normal or Gaussian, and based on that you get like the output. right? So simply you are using the Gaussian namespace, you are calling it, and you're fitting it. It's used for classification. Okay. Now you can see it's activated. Finally, we'll use the Gaussian namespace for prediction.
Not Gaussian name. This is something new term. This Gaussian thing.
Okay, okay. So Gaussian namespace. So if you have studied namespace, Gaussian namespace is a specific variation of namespace where you are assuming the distribution are normal. So let me show you. Okay. So Gaussian namespace is a classification technique used in ML based on the probabilistic approach, which is like namespace only, and it assumes you have a Gaussian distribution. Okay. So over here, Gaussian means like normal distribution. Okay. I think everyone is aware of normal distribution, right? So okay, this is normal distribution you already know, but hmm. So this is the equation of normal distribution. Like if I open the normal distribution or Gaussian distribution Wikipedia, okay. In normal distribution, how do we find out the probabilities, right? We find out the probabilities of the y variable using this function PDF, right? 1 upon sigma 2 under root 2 pi into e 1 minus, into e minus 0.5 x minus mu divided by sigma the whole square. Same equation is written over here as well. Okay. So here, this is what will give you the probability, and it will tell you what is the probability of a particular observation being classified in a particular group, right? For example, defines the probability of one observation being one of the groups, right? It's simply used for giving the probabilities for classification. Okay, so this is fine, 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 this is fine. Okay, so main logic is like based on the Gaussian distribution only because you're using that particular formula for getting the prediction. So obviously you're assuming that your distribution is normal. I'm just seeing if we have a better visualization for it. Okay, so like in names, you are simply considering the probabilities, right? Where you consider the conditional probabilities, like this one, right? You're using the naive theorem to apply and get the output. In Gaussian, apart from using the normal distribution for computing the probabilities, this is fine, this is fine, this is fine, this is fine, this one, yeah. So this is what I was looking for. So if you see over here, you are computing the probabilities, right? These probabilities are prior probabilities which you compute for naiveness. Okay, so you apply the formula of naiveness, you will get your properties. Hmm. So yeah, this is the main logic. Hmm. So if you see over here, you are having multiple variables, right? And over here, using the multiple variables, you'll be computing the conditional probabilities, like how we do it in Navis, where we compute the conditional probabilities for different words. Same thing will apply over here as well. Okay. And based on that, you you'll plot for each variable the distribution. Okay. So over here, the distribution may not be normal. Okay. But here it's showing that it's a normal representation. Okay, but assume that it's an assumption that it's a normal distribution, but in reality, it may not be a normal distribution. Okay, first thing. Second thing, you check the normal distribution, you plot the mean, and you get the like mean and standard deviation. Same thing you'll do for the other category. Like there are two categories. The y variable is loves. Second y label is does not love. Okay, so you're classifying whether someone loves that particular movie Troll 2 or they do not love the movie Troll 2 based on whether they are like having popcorn, soda, and candy. Okay? So based on this, you will have two distributions created, one from your one category and another from other category. Okay, let me just go after this. Okay, so now you're plotting both the ones. Okay, but you can clearly see that one of them looks normal, but other one doesn't look normal, and that is completely fine. Okay, you compute the mean and standard deviation both for both of them. Let me just increase the pace of this. You will draw for soda, you will draw same for soda, you'll draw for candy, and similarly you'll draw for candy for both the Y categories. Okay, once you have received both of them, once you have received both of them, uh, now you will apply the formula for Gaussian distribution. Okay, that's what it's going to do. So this is fine, this is fine. So this is saying like you have a next X variable coming, like a test data, where this is the X value, this is the soda pop value, this is the candy value, and this is the third value. Okay, so this is what is saying. The probability that we want that a particular word belongs to a particular category, like loves or does not love, is going to be based on the training data, and we are going to compute this probability using this distribution. Okay, how distribution? Because we know in normal distribution we can simply use the normal distribution formula to get the probabilities, right? I just need to pass in this formula what is the mean and standard deviation, right? Like here in this particular formula for PDF, I just need to know what is the mu and what is the sigma. If I know mu and sigma, I'll get the probabilities, and that's what it's saying. Okay, so going back, so it will simply use the formula, generate the probabilities, and that's it. So let it compute all this naive-based things. This is fine, this is fine, this is fine. This is your prior properties, you have this. Right. So all these computations that are happening, right, all of those things, these are all based on your probability logics. Okay, so you can watch this video in detail. Here, they have not explicitly mentioned the formula. They have directly taken, directly telling you the values and saying that we are getting it from distribution. But how they are getting it from distribution is through the formula itself. So if you feel that after watching this video, you did not understand how did they get the properties, the answer is just apply the formula. Okay, cool. So if you want this video, I can share it. By the way, like Gaussian name base is not a part of our curriculum for now. Like I'm just telling this as an extra thing, but it was not supposed to be taught to you. Anyways, uh, good that we had discussed. Okay, so you can get the link from you. StatQuest, one of the best resources for anyone to quickly start learning statistics, machine learning.
Please share that Kaggle link for data download.
Sure. Okay, so everyone can download the data from you. Yeah, you have around 49,000, 50K reviews almost. Okay, let's move forward. I'll share the regex link as well. Okay, so Gaussian naive Bayes is actually a very good algorithm, I would say. Like, it's much better than naive Bayes. Why is this? All right, so it's much better than naive Bayes, and that is why we are using it. Like, it's much more robust compared to naive Bayes because it handles outlier as well, and a couple of other advantages which you can read by yourself. Over here, we are using it for prediction on the test data and we are simply computing the accuracy and confusion matrix. So you can see, since it was not a imbalanced data set, it was a balanced data set. Accuracy, we can use it, right? Had it been imbalanced, we would have used probably present recall F1 score. But since it's not imbalanced, let's go with accuracy only. Accuracy over here is 63% with Gaussian inverse and using count vectorizer. Next, we try out, we can see the confusion matrix. You can clearly see that there are huge number of errors. We try out random forest. With random forest, you can see like we call it, we fit it, we predict it, we get the accuracy score. The accuracy score improves to 85%, which is quite good. Okay, so now we'll use a hyperparameter tuning method. So right now, count vectorizer is converting it into 48,000 columns, right? The X string, right? So now instead of convert to 48,000, we have a hyperparameter where we can decide, instead of keeping the all 50,000 words, keep only the top 3,000 important words. Okay, so count vectorizer will identify which words are probably having the least sparsity, and based on that, it will include only those 3,000 words. Okay, and that's what we are specifying over here. Like if I show you count vectorizer max features, let's go to the documentation. Okay, just to speed up the time, and let's say you don't want unnecessary, like bad words which are not contributing anything, you can do that. Okay, so you see, build a vocabulary that only considers the top max features. That means the top words ordered by the term frequency. Ordered by the term frequency is nothing based on the count. So wherever you have counts present, those will be taken first. The other ones will be taken, like they will be probably given lesser priority. Okay, so in a way, you will get words which have higher count, right? So they won't have zero; they will have probably higher counts. Unless and until you end up with the counts, you will then probably start taking zero count based numbers, and that is why it will like take care a little of sparsity. Okay, so that's it. You specify the top words that you want to use. You fit transform on the trained data again with the new count vectorizer. You transform the test data. You again build the random forest because we got the best answer with random forest. You fit it, you predict it, you check the accuracy. By the way, you can try Gaussian name-based as well on this, no issues. You're getting 83%. It's not a huge improvement over this. So maybe since we have limited the count of words, some information would have been lost, right? Compared to 50,000 words, if you're training with 3,000 words, there can be some information loss, but still I would say this is a better model because it's simple, right? Again, the rule of Occam's razor, instead of having two models both giving you same accuracy, like similar accuracy, choose a model which is simpler. So this is a model which is much more simpler, and the accuracy is not much different, like only for 1.5 or 2% improvement. I don't want to increase my data size by like thousands, right? Instead of 3,000, we are taking 50,000 in the first one. Okay, next we'll try one more method. Here you can specify another hyperparameter, which is n-gram range. So n-gram range takes care of if you want to create a bigram or a unigram. So, okay, so here you can specify the min and max for n-gram. So basically here you're specifying that I want to create words which are either unigram or bigram, right? So you'll create the matrix, you'll create the counts by considering first unigrams, like the movie, all this are separate words, right? You'll convert all of them, you'll get the count of the movie is good. But if you use a bigram, what will happen? It will take two combinations. The movie will be one entity, movie is will be another entity, is good will be another entity, and if you add something after good, that will be another entity, but you don't have anything after good. and and freeze. That's how your bigram will work. So compute the numbers based on whether you have a unigram and a bigram. Okay. So over here, let me run this. So again, you're specifying like keep it to only 5,000 top words. So it will compute the unigrams and bigrams and identify which combinations of, let's say, unigram and bigram are having the highest count. Whichever ones are having the highest count, it will take that as the take that for the final 5,000 features. So what can happen is, let's say you have combinations like movie good. Let's say this is one bigram, which probably has the highest frequency, let's say around 500. Then you may have, let's say, another word, which is, let's say, good. The unigram good may have 490 frequency. Then you may have another bigram, let's say, boring bad. Okay, let's say this is a bigram which will be considered as one entity, and this may have, let's say, 470 frequency. Then you again may have a bigram, let's say, a terrible movie, right, with, let's say, 400 frequency. Similarly, you may have another one, a unigram interest, right? So here you are creating all these things based on unigrams and bigrams. Okay, so you're getting like 83% accuracy, not a huge improvement, but uh, still it's fine. Okay, still it's fine. Okay, now we are using TF-IDF, again a count-based approach. So from feature extraction, import TF-IDF vectorizer, call the vectorizer, fit transform, transform on train and test respectively. Call random forest, fit it, get the predictions, get the accuracy. You're getting 84, a little improvement over the previous one, but still not beating the first one, which was 85%. 85 was the highest, right? Okay. So you're getting 85, but still, I would say these models are much more better because 85 was with 50,000 columns, right? Here you are getting like 83 with only 3K columns. You are getting again 83K with like 5K columns. So I think this, in my opinion, is the best model until now. Okay, with TF-IDF, TF-IDF is again like good. You're getting like 84, which is fine. But still, I would say this is much more similar because even with TF-IDF, a little computational cost gets added. Right? So until now, we have received 84% accuracy. Now we have been using count-based approaches, right? Now we'll be using Word2Vec, right? To use Word2Vec, we have different places from where we can get like the resource of Word2Vec, but it has been created by officially by Google. So let me just fetch it from here. So let's just copy this. Let's paste it over. Okay. So Jensen is the library where you'll get the Word2Vec code. Okay, so this is Gensim library where you can find the Word2Vec embeddings. We have already gone through the discussion of this. We have discussed continuous bag of words, skip gram, all these things. Okay, so you can see the usage. It's very simple. You need to just import these two lines to import the Word2Vec, and actually you just need this one. You don't even need the common text. Common text is just an example to show you some common like sentences. We already have the data, so I don't need the text. You can simply import the Word2Vec from gensim.models. Activate it, pass the data. You have some hyperparameters which we'll talk about, and finally save the model, like if you want to save it. Very simple. Okay, so let's do this. So we'll train it. Import gensim.models, import Word2Vec, import gensim, this is fine. Okay, yeah. So over here, if you see, you are pre-processing the data by tokenizing it. If you remember, we had discussed with Word2Vec, you need to tokenize the data, you need to split it, and that's what will happen over here. In Gensim, you have a function called a simple process, which helps you to pre-process the data. In simple words, it will just tokenize the data. Okay, so simply use Gensim simple process method to process your reviews, which are present in your text data. Okay, so over here, instead of text, we need to write review. Okay. And dataset train. Okay, so what? So this is for a different code. So you just need to make a little modification over here. Dataset train review. So this is our X train. What was the original name of our data? X train. Right? Let's get X train. Reviews. Okay. So what will happen? This will go inside the reviews one by one, and it will take each review. For example, over here, let me just print review. So what will happen is it will go inside this and it will start printing all the reviews one by one. Yeah. Okay, it has printed all the reviews one by one. Just add. Okay, so okay, so you can see like this is the first review, this is the second review, this is the third review, and so on. Okay. Anyways, let me hide this. Okay, so you're passing the review in this particular list, and you are getting the list of sentences, right? Because I said it's a it's an algorithm where you need to tokenize the data, right? So here you're pre-processing, you're like tokenizing all the sentences, right? So if you see over here, you are getting the list of sentences which are tokenized, okay? Which means you have splitted the sentence, okay? Here we are doing the pre-processing at a review level, not at a sentence level, okay? So if you pass one sentence, it will pre-process it and break it into multiple words. If you pass the entire review column, it will break it into multiple sentences, okay? And that is what will happen over here. It will break it into multiple sentences, and those sentences will pass it into Word2Vec, where we are defining some parameters. So we can quickly check all these parameters. So first is vector size. Okay, so if you see over here, vector size. Uh, yeah. Okay. So I think it's quite self-explanatory. You can understand my name only, but let me just show you. Size. Yeah, this is the one. So vector size, it says the number of dimensions n of the n dimension says that GenStream maps the word into, right? So over here, you can specify um, how many words you want to finally represent it, right? So as I said, in Word2Vec, you use deep learning approach, right? You use shallow deep neural networks, which finally give the output in what number of dimensions you want, right? Do you want to show the output in represented 5 dimensions, in 7 dimensions, in 100 dimensions? And that's what it's saying. In what dimensions do you want to represent the output? It should not be too high, not too low. If you keep it low, there's a possibility that you may underfit. You may not be able to show the complete, like if you need like 100 words and you're only passing 10 words, like 10 dimensions, you won't be able to represent it completely. And if you're passing unnecessary extra dimensions, what will happen? Let's say you need only 100 dimensions, but you are passing 500 dimensions. What will happen is the other like 400 dimensions will be unnecessary, unutilized, right? Which will cost training issues, right? Because you're adding noise, you're adding like bad data, which is not required. Okay, so this is vector size. Workers is nothing but it's used for parallelization. Like the more workers you are, the faster your models will learn, because it will divide your training thing, like conversion of Word2Vec on different processors. So all these things will run in parallel. Okay, what was the other hyperparameter? Workers is 4. Okay, that is fine. That means you're dividing on 4 processes. Window as 5. Okay, let's see window. Window, and what was the next one? Min count. Okay, so we'll see window, is it there? Min count. Okay, so min count is okay. So see, words that appear only once or twice in a billion words are probably uninteresting, typo, and garbage, right? So this is just ensuring that minimum that number of types, like whatever you specify as min count, like if you specify 5, minimum 5 times that word should appear. Because if it's appearing less than that, then probably it's not an interesting word. Like if it's occurring only 1 time or 2 times, it's not something which is probably adding any meaningful uh, interpretation to our data. And that's what it's saying. So it's best to ignore them. Okay. So min count is fine. Only thing that is remaining is window. Okay. So let me show window as well. Window also should be over here only somewhere. Yeah, I don't think so. They have mentioned over here. Okay, so window, I mean, we can find it. We'll just have to search it on the documentation. But I'll just explain you. Window is nothing but what we had defined when we were defining the bag of words. That so not bag of words, but Word2Vec. When you create Word2Vec, you need to define a window size, right? You need to define, do you want 3 window size or do you want 5 window size? And based on that, the window keeps shifting. Like first you'll start with the, let's say, window size of 3. Then you will take the first 3 words. And then you'll go to the next combination of 3 words. Then the next combination of 3 words. Then the next combination of 3 words, right? And based on that, you will generate your Word2Vec. So that's what it's saying. How much window size do you want? Okay. I hope you all remember the working of Word2Vec. Okay. Cool. Just a second. Okay. So over here, let's let's do this. So you have vector size of 100, but I don't want to limit it to any particular dimension for now. Let it be by default. Let it identify for whatever dimension it feels, and we can just run this model. Let's train this. You'll be able to see the sentences that have been broken down. So this most probably will be broken down by full stops. So it will train, and after that we'll utilize the prediction. Okay, it has completed the training. Let's see the sentences. Or let's probably keep it to only one sentence for now. Let's see only the 0 sentence. Okay, so now if you see over here, oh, it has pre-processed by words. Okay, so it has not pre-processed by sentence, but it's pre-processed by words. It has broken all the individual words. It has tokenized it. Okay, that also is fine. So you are breaking it by words, and then you are creating the Word2Vec model. Okay, so your model has been trained. All we have to do is just uh, like the words have been converted to numbers. That's what I'm saying. Okay, one thing that we are going to talk about is average Word2Vec, which we have not discussed right now. So we'll discuss about average Word2Vec, and after that, we'll complete this problem. So let me add it over here. Okay, this is fine, this is fine, this is fine. Return feature register. Okay, so this is the main part. Like once your model has been uh, trained, all you have to do is just apply the Word2Vec model to transform the text into numbers. And using this function, you'll get the feature vector. So we'll pass the review. We'll again we'll pre-process the review to apply the Word2Vec. Once it has been converted to words, individual words, like how we have converted this one, we simply need to apply this. To apply this, we are going to use model.wd. So this is nothing but word vectorizer, which will convert the words that you pass into vectorized form. Okay. So only thing we need to do is just run this. So let me just run this. Okay. So we'll pre-process both of them. We'll pre-process, train and test. Okay. So this is fine. This is fine. So let's change this. Let's copy from here. This should be X train and another one should be X test. Okay, so review to feature is the function name. You're calling the feature, you're passing all the reviews for all the reviews in training, for all the reviews in testing. So this will convert all the feature. Let's see. Okay, until it gets completed. Now, uh, once the text is converted to numbers, we'll simply train the model. So for that, we can try out multiple models. Here they are trying out logistic regression. We can try out our models like random forest and all that. Okay, so now you have simply converted it to the numbers, and now we can quickly check if they are representing numbers. Okay, so you can clearly see that it's a number form where you're converting the uh, data, the reviews into numbers. The best thing about this is you don't see sparsity, right? It's highly dense. There's no zero. Okay, so in a way, it's capturing like uh, semantic relationships. It's trying to understand which words are similar to each other. Okay, so that's what was the issue with count-based approach. But with Word2Vec approach, that problem is at least solved. Okay, now we'll simply train the model. So we can just copy the above code. Yeah. Okay, let's compare with random forest because until now we have been comparing with random forest. Okay, this is your extreme features. Actually, we should have mentioned over here. Extreme and ext test. Extreme and your y tree and x test.
In the words we are seeing after feature, they are words or sentences. The numbers,
Uh,
sorry.
this one that you're seeing,
Yeah.
this is only for first review. So all these are different words, vectorized form.
Okay, words. Okay.
Yeah. So this is for a single sentence.
Okay. One sentence is coming here. Okay.
Yeah. We have taken only one sentence. Uh, okay. So we'll fit it on extrain features. We'll pass y train. We'll predict for x test. We'll get the accuracy for y test and y predict. Okay. Let me just run this. We had stored it in y train only, or did we define it something else? Yeah, it's y train only. Cool. It's correct. Okay, so let's run the random forest. We have all the set of numbers. X, you can clearly see it's 2D, Y train is 1D. So this will run fine. X test, let's predict it. Has this executed? Okay. Let's see the accuracy. Okay, let's hope it gets better. Okay, one thing I didn't tell you. So I was talking about average Word2Vec. So I'll just tell you what happened over here. So we are converting it to vectorized form. And over here, we are taking an average of Word2Vec. Okay, so average means like, okay, so we are getting like 76% accuracy. That means we need to hyperparameter tune this to improve the accuracy. So we'll talk a little more about this Word2Vec first. Just 5 minutes. Um, so over here, we had discussed Word2Vec, right? Where we discussed the words, whatever words you have, let's say interesting, bad, right? All of them are represented by the dimensions that you specify. Like if I specify 10 dimensions, they'll be represented in 10 dimensions, right? And you will get for them for each dimension, like what is the number, like 2.5, 3.2, minus 1.6, and so on, right? Because it's a deep learning based approach. Similarly, over here, you'll let's say get 4, 3, 2, and so on, right? Over here, you are getting this for a entire word, right? You are representing words in form of numbers. Okay. In our code, we have taken sentences instead of taking words to represent the dimensions, but it doesn't matter. Like if you take review one as well, the logic will remain same. So let's say this is your re, uh, review one, review two. Okay. So in our code, we are taking review based, but you can take it by word based as well. So now for each review, you have converted the word to it. You have converted the word into numbers. So now what we are simply doing is we are taking an average. Okay, we are taking an average because for a particular review, I will just check what are the different words. Let's say the review one has words like interesting, bad, and so on, right? So what will I do is I'll simply see what is the final average of all the corresponding same dimension. Okay, for one review. Okay, this is for only one review. So for one review, I'll get a representation where the first dimension will be an average of let's say 2.5 and 4, which is 6.5 divided by 2, which is 3.25. Similarly, for the other dimensions, I'll simply take their average, their average, their average, their average. I'll take a mean. Okay. Because if you have, let's say, if you are tokenizing it based on different words, each word, let's say review one has interesting, bad, both. Interesting represented by this, bad represented by this, right? Now, for the final review, like if you want to show the answer at a sentence level, at a review level, right? You need to check for all the words, like for interesting, for bad, for good, for movie, all the words which are there in the review one. What is the vectorized form which you got from Word2Vec, right? That's what we got. And from this, to represent review one in terms of only one single representation in let's say 10 dimension, that means 10 columns over here. How can we get it? Simply take an average of this, average of this, average of this, average of this. This will give you 10 dimensions because you're taking 10 averages. And that's how the final answer is arriving. Okay, so what you see over here, so we had discussed at a word level, we did not discuss it at a review level, right? We had discussed like how to convert interesting, bad to representation, but how do you want to combine everything to get an answer for review? You have to take an average. So this is called as mean Word2Vec. Okay, so you simply take an average and that's how you generate the feature. So if you want to see the extract features, I can quickly show you the first review. So let's take so this is let's take the first review. So if you see the first review, here you have all the averaged numbers. Like these are the number of dimensions that we have. We can quickly check the length of this. So over here you have 100. Okay, I think 100 is the default vector size, and that is why you are having 100 dimensions in the reviews. Okay? For each of the dimensions, you have taken an average for all the words that would have been present. So this is by first average of the first word. This is for the second word, the average for it, and so on. Okay, so now obviously we need to hyperparameter tune this, so we can obviously play around with this, but I leave that for now. Since we are already at 9:35. So we can change the min count, we can change the window, we can change the vector size, we can play around with the other hyperparameter tunes. We can even use hyperparameter tuning methods like grid search and all that to arrive at an optimal value. Okay. So over now, until now, whatever we have done, based on that, I'll assume that random forest with 3K features was giving me the best answer, even though accuracy was not the best, like 83 compared to 85. But still, according to the Occam's razor rule, it's a simple and the best model. All right, good. So let's wrap today's lecture with this. By the way, the reference for this code I had taken from the channel Campus X. So if you want to probably just revisit the original source, you can just check out the playlist of Campus X as well. I have taken reference from there only. Okay. Other things I have for this notebook.
Yeah.
Oh yeah, I'll share this one only, notebook only. So I just modified the notebook, so the code is a little different, but you can still check it out. Okay. So this covers your Word2Vec. This covers your ML algorithms, the classical ML algorithms that we have seen. In next lecture, we'll talk about deep learning approach, where we'll talk about how we can use, let's say, RNN, LSTM, BERT models to solve the problem. And in the final lecture, so I think it's Monday, Tuesday, Wednesday, tomorrow we'll discuss about deep learning, and day after tomorrow we'll discuss about POS tagging, like how do we build the POS tagging models. And I think we may have one more lecture on Thursday, which may be on what is remaining. You have POS tagging. Yeah, if needed, we may have a lecture on chatbots because we have not discussed chatbots. So we'll discuss chatbots in the final lecture.